Hi, my name is Brian, and today we are going to introduce limits and then evaluate limits numerically. Let's go ahead and start with the definition of a limit. So we're going to let f of x be a function defined on an open interval around a, except possibly at a. And the notation is going to look like this. So we have LIM, standing for limit. We have x, arrow a, f of x equals L. So the LIM is going to stand for the limit. Down here is what x is going to approach. So all the values of x are going to get close to a. Now as that happens, all the y values, so evaluating your function at those values really close to a, we're going to get y values really close to L. Another way of looking at it is if you were plugging in values of x close to a, what would you expect the y value to be? And what we're going to do is we're going to go through a table of values, plugging in x values really close to some fixed number and see what the function values do. So the example we're going to do is going to be the limit as x approaches, say, 4 of the function 2x minus x squared. And I want to know what that equals. Now you can just simply plug in 4 to see what you get, but that's not a limit. We want to plug in values really close to 4 and see what this y value is. So we're going to set up a table, and we're going to do it in 2 different tables. So let's start with what we call the left-hand limit. Now left-hand limit would be selecting x values really close to 4, but to the left-hand side of 4. And as this table goes down, you want these numbers to get really close to 4, just not 4 yet. So we're going to choose, say, 3.5, and then 3.9, 3.999, and so on. Let's do one more. So 3, 9, 9, 9, and 9. All right, so I wrote down the table of values down here, so I'm going to keep looking. But we're going to plug each one of these in to 2x minus x squared. So when I plug in 3.5 into, and again, you can type this into a calculator. What I'm going to do is off over here, I'll put the calculator in what I typed in. So plugging in 3.5, I get negative 5.25. And then I plug in 3.9, and I get negative 7.41. 3.99 give me negative 7.9401. 3.999 give me negative 7.994. Finally, 3.9999 will give me negative 7.9994. So you can see from the table that when x is getting really, really close to 4, it looks like these y values, or function values, are getting really close to negative 8. So I would say that, as of now, the limit of my function is going to be negative 8. But since all of these were selected to the left-hand side of 4, we have to indicate that on the limit. And then we do that by putting a little minus sign here, standing for the coming from the negative side or from the left-hand side of 4. So we can go ahead and do the right-hand limit. All right, so the table will be set up exactly the same way, but selecting x values from the right-hand side of 4. So we will start with, again, I wrote them down ahead of time, and we get, so I chose 4.5, 4.1, 4.01, and, all right, one more, 001. Nope, 0001. All right, so 4.5 again on the calculator, which is now over there. Plug in 4.5, we're going to get a negative 11.25. And then 4.1 is going to give us negative 8.61. Sorry about that. Negative 8. When I plug in 4.01, I get negative 8.0601. And then I'll just finish off the table. 0.06. And negative 8.0006. All right, there might be some rounding here. So now as this gets close to 4, again, this is going to get close to -8. So I can write that the limit as x approaches 4 is -8. But these were all x values selected to the right-hand side of 4. So we indicate that in the limit by putting a positive sign, meaning coming from the positive side or the right-hand side of 4. All right, there you go. Finding limits through evaluating tables. All right, bye.